We're going to solve this polynomial inequality, and then we're going to graph the solution set on a number line, and then we are going to express that solution set in interval notation. So here is our polynomial. It is an inequality. You see it's greater than. And two things you need to make sure of. First, make sure that there is a 0 on one side. All right, and I already had a smiley face in there. All right, so 0 on one side, and then we need to factor the polynomial. So let's factor this here. We're going to get 2 factors. You can see that this polynomial has a leading coefficient of 1. I call that an easy one. It's going to be x times x gives me x squared. 2 numbers here that multiply to give me 18 that are going to add to give me 9, and that's going to be 3 and 6. They both have the same sign, and both of them are negative. Okay, so that's factoring easy 1. If you want to check, you can multiply this out and you will get the polynomial above. So we need to find out when this polynomial is greater than 0. So I'm going to do a little sketch over here on the side. I'm going to do a sketch. I'm going to show you what this graph looks like, what this polynomial looks like. All right, we have a rough sketch over here, and you can tell that this polynomial crosses. It has x-intercepts at 3 and 6. So if you can look at it and see that when is this thing greater than 0? Well, it's going to be greater than 0 at the parts that I'm going to put in, let's say, yellow. All right, it's greater than 0 here, and it's greater than 0 here. Is it greater than 0 on this spot right here? No, it's not. It's actually at 0. Okay, so I'm looking for 2 intervals that are going to be good, and it's the intervals where the graph is yellow. Okay, now we don't have this, but I'm just showing you what we're looking for. This is how we're going to find out. Here is my number line, and I have 2 points of interest. They're going to be boundary points. One of them is going to happen at 3, and one of them is going to happen at 6. Okay, there's the 3, there's the 6. And these boundary points have split up this number line into 3 intervals. Okay, you see one here in the yellow, one here in the pink, and one here in the red. Now, I need to test a point in every interval. I need to test 3 points. If I test a point in one interval and that point is part of my solution, everything else in that interval is part of the solution. I'm going to accept the entire interval that I just checked. But if I get one point, a test point that does not fit in the solution, then nothing else in that interval is going to be part of the solution. So let's pick some points to test. I'm going to test something out here. Why not 0? It's usually easy to plug in. Something between 3 and 6, let's say 4. And something greater than 6, why not 10? Okay, it doesn't matter what points I test, just as long as they're in that interval. So let me go to the original equation. Let me plug in a 0. Here's the original equation. Instead of x, I'm going to plug in a 0. And instead of x here, I'm going to plug in a 0. Let's see if this gives me something that's true, that's part of my solution. 0 squared is 0. Minus 9 times 0 is 0. So I get 18. Is 18 greater than 0? And the answer is yes. So I'm going to put a yes here where the 0 is. And everything in this interval is going to be part of my solution. All right, let's test number 4. Let's test 4. Instead of x right here, I'm going to plug in the number 4. And instead of x right here, I'm going to plug in the number 4. All right, let's see what I get. Negative 4 squared is 16 minus 9 times 4, 36, plus 18. All right, let me get a calculator. That gives me negative 2. Is negative 2 greater than 0? And the answer is no. So nothing in this interval will be part of my solution. All right, let's test our last value of 10. So instead of x here, I'm going to plug in a 10. And instead of x here, I'm going to plug in a 10. All right, 10 squared is 100 minus 90 plus 18. That's going to give me 28. Is 28 greater than 0? Yes, it is. Okay, so this test point is included in the solution, and everything else in this interval is also included in the solution. So I'm going to shade it here. Now, what happens at 3 and at 6? Remember, if you come over to the graph, is it greater than 0 when it hits 0? No, it's not. Is it greater than 0 when it hits 6? No, it's not. Okay, I said 0. I meant 3. So at 3, it hits 0. 0 is not greater than 0. All right, same thing with 6. And you can tell from our inequality right here, that's your hint that we're going to use parentheses and not brackets. If it had a line underneath, then I'd use brackets. So I need a parenthesis on my graph right here, and I need a parenthesis on my graph right here. All right, I like to label negative infinity, and I like to label positive infinity. So I have two different intervals that are part of my solution. It's the one on the left, everything from negative infinity to 3, and also part of my solution is everything from 6 to positive infinity. So they're going to want it in interval notation, which I'm going to put right here. You can pretty much just copy down everything from the graph. So negative infinity to 3, and then 6 to infinity. Negative infinity to 3, that's one interval, in union with 6 to infinity. And that's my interval notation.